Next, light. In details, I will would like to. In details, I want to discuss about it with you about light. I know most of you, even me, are familiar with this chapter, but in this lecture, we will try to expand. We will try to extend this topic. We will understand meaning of this. We will see law of reflection. In details, we will try to understand about reflection. In details, we will try to understand about refraction of light. In details, we will have discussion of mirrors, image formation by mirror, by a convex mirror, by concave mirror. We will understand what is this index. We will understand lens, convex lens, concave lens. All this will be covered in this lecture. So I would say just stay at the end. It is your choice. Now I want to start. I want to start. First, meaning of light. Light gives us. Light provides us. We are able to see anything. We can see anything because of light. Light falls on the surface of an object, then it reflects into another direction, into different direction, and some direction of beam of ray comes reach to our eyes. Then we are able to see all these objects because of fall light fall on the subject, then it turned into different direction. Some directions of light came into our eyes. That's all. This was meaning of a light. Now, uh, what is a luminous object? What is a non-luminous object? Luminous object and non-luminous object. I will tell you right now, I will tell you some important word, definition of some important words so that our basic can be complete. Okay. After understanding meaning of light, we are understanding what luminous object, non-luminous object. Remember, any object, if that object has their own light, any of this object, can you say has this object light their own? No. This object cannot emit their own light because this object does not have their own light. That's why. Any object you can take, if that object is not able to emit because they don't have their light. Any object cannot emit their own light, those objects will be considered as luminous. I think non-luminous, okay. Non-luminous object. If an object can emit their own light, for example, sun, for example, the star, all these candle emits their own light, sun emits their own light, star emits their own light. That's why all these are objects, but they can emit their own light. They emit their own light. That's why we are saying all these objects will be considered as luminous object. So we divided two objects into different by defining. Remember, luminous object. There are two types of object. First natural, second artificial. Yes. Okay. Got it, got it. Over. Now next, what is a transparent object? What is a translucent object? What is a opaque object? Now we are understanding all these types of object. First, opaque object. Remember, any object. It is a better example. There should be what? Three things. First, source light. Second, object. Third, a screen. Third, a screen. Why a screen? I will tell you. Light is compulsory so that we can see object. Now light is coming. Yes, light will fall on this object. Now light is a turning. Light is direction of light is a turning into another direction, but it is not a passing through this object. Why? What is the reason? Reason is just what? Because it is blocking the light. It is not giving allow. It is not giving permission to pass this coming light. If this object is not giving permission, if this object is blocking the light, it means we can say this object is opaque object. We can consider like that objects as a opaque object. Opaque object will block the lights, and that's why they this they for they form what shadow behind this. Behind this you can see shadow of this object because light was not passing, light is not passing through this object. That's why this will happen when object is opaque. Here behind it you will be able to see shadow of this. That is how shadow is formed. Always remember, color of shadow will be always black, not this type, only black. Okay, only black. Only black. Now, if here is not a screen, then you cannot see shadow of this object. That's why we need a screen so that we can see shadow of an object. Shadow of an object. So here, this is the shadow of this object. Why this shadow? Because light is not passing through this object. That's why. If object, this was opaque object. This was the definition of opaque object. Now second, transparent object. What will happen with a transparent object? Transparent object will allow to pass the light. Light can pass through that object. If the light is passing through that object, it means that object is transparent. Transparent. Even in front of us, there is a transparent glass. Okay, big transparent object. What will happen? Now we can see area behind this transparent object easily because of it is a transparent. Okay, we are able to see this. We are able to see behind area of this object from this side. It will happen when object is a transparent. Now next, translucent. Translucent will provide blur view. Some lights will be blocked by that object and some lights will pass through that object. Now, like that object, we will consider as a translucent object. Translucent object. Translucent objects are those objects which can block some lights but which cannot block at the same time that object cannot block some lights. Then that object will be considered as translucent object. That's it. That's it. Now reflection of light. Reflection of light. What is the reflection of light? It is a reflection will be what? Here we are talking about a reflection of light. Of light, not reflection of me, reflection of this world, reflection of this building, reflection of this house. No, I am talking about reflection of light. We can see reflection of something object. Okay, we can see reflection of a object apart from this light. But here we are talking about reflection of light. Even you can see reflection of this in mirror. But here we are talking about a reflection of light. A reflection of light. Here always remember, you will take a opaque object like that. Okay, this you consider this as a opaque object. From light is coming from source light, like this. Of course, some light will hit on this object, on surface of the object. Of course, here you can see it is hitting on the surface of the object. Now, if it is hitting, if object is opaque, of course it will turn into another direction, as we saw, as we studied definition of opaque object. If this is opaque object, and here remember, surface is plane. It is hitting, this light ray is hitting on the surface of this object. It is turning into another direction. This turning of this light is what? Reflected ray. Always remember. This is ray, this is also ray of light. But this ray is not coming direct from source light. It is coming after hitting on the surface. That's why it becomes definition of a reflected ray, because it came by hitting on the surface of the object. Now this ray which is coming from this source light until the hitting till the surface of the object, from here to till here, we will consider this as a incidence ray. Otherwise you can say incident ray. Okay, so this is meaning of incidence ray of light is what? It comes from source light and it hit till the hitting of on this surface. We will consider this ray as an incidence ray, and this is reflected. There can be a lot of reflection of a light, yes, if there are a lot of objects. As you know, reflection, this is one ray reflection. Some reflections can go this side, some reflection can go this side. So that's how there will be multiple reflection. Now we saw what? If this is object, and this is a plane mirror. This is plane mirror, and here you can see it will hit on this object and it will turn in some reflection ray will reach to this object, and that is how this plane mirror will fall. This plane mirror will form this image of this object because of light hit on this surface. That's why this plane will form image of this object. Clear? That is how you see our image. That is how you see your image inside mirror, because a reflection of light. Light will hit on you. Otherwise, light is also hitting on the surface of a mirror. Both are working to form a image, to form your image inside mirror. Okay, so it is happening because light is falling on the surface of a plane mirror, on the surface of you. There we saw meaning of reflection of light. Now here we can draw a normal line so that we can measure angle of incidence and angle of reflection ray. Always remember, if a plane is a surface, condition is what? Now we are talking about law of reflection of light. If a surface is a plane, if a surface is plane, then always remember this will be equal to this. As you know, this is what 90 degree, this is what 90 degree. Both sum of both will give 180 degree. Of course, because it is a straight line. That's why sum of this angles will be 180. Because of this is plane. Now law says this I will be equal to this I. I am not talking about this. If this both will be equal to each other, so of course this both will be equal to each other. But always remember, this will not be equal to this angle. This will not be equal to this. Okay. Question will ask, what is the angle of incidence ray to the normal line? So it means from here to here. Question can ask like that, what is the angle of incidence ray between what is the angle from incidence ray to the ground, to the plane surface? So you will consider this angle. Okay. But I am not saying this will be equal to this. No, this will not be equal to this. This both will be equal to each other. This both will be equal to each other. This is what law of reflection of light says. Clear? Clear. What is? Now, second. First one, angle of I will be equal to angle of R. If this is a 45, this will be 45. Second what? This normal line, this incidence ray, reflection ray, all this will lie on same plane, not this that. All this line will lie on same plane. Clear? Normal line, reflector ray, incident ray, all this will lie on where? On plane surface. That's it. Now something else apart from this. Now something else. Spherical mirrors. Spherical mirrors. Spherical mirrors. What is a spherical mirror? A spherical mirror looks like this. From this spherical mirror, we will get two types of mirror. First will be concave mirror. Second would be convex mirror. Convex. This one. Now we are going to understand what is a concave mirror and what is a convex mirror. Both we will get from a spherical mirror. We will take this part and this part. Okay, we will take both parts, but name of both will be something else. First we can easily draw, this is one and this is one, this is another one. If this is a painted area and on this painted area is where? This is painted area. Now what will happen? If this side is a painted area and this side is a painted area, what is the meaning of this? Meaning of this is very simple. It is trying to tell you, if a painted area is this side, it means this will be reflected surface. This surface will be reflecting. This will be reflecting surface. Painted area, we will not consider painted area as a reflecting surface. Clear? Without painted surface, we will consider as this is without painting area surface. We will consider this as a reflecting surface. Now this is inward. This is inward. Inward means inside. Outward means outward, outside. So of course this is inside. It means it is a cave. It is a cave, concave, concave. If a reflecting surface is inward, we will consider this is mirror. This is mirror. If inward, if a reflecting surface is where inward, this is, then we will consider this concave mirror. If a reflecting surface is outward, this is outward surface. Now this is a reflecting surface because inward surface is painted. Inward surface is painted. That's why. That's why outward is not painted. Outward we will consider as a reflecting surface. As a reflecting surface. This is a reflecting surface. You can say this is a reflecting surface. Reflecting surface. Clear? Clear. If a reflecting surface is outward, we will say convex mirror. Convex mirror. Clear? Clear? Here it is a what? Inward. And this is outward. This is outward surface, this is inward surface. We have identified which one will be concave, which one will be convex. If a reflecting surface is inward, we will consider that mirror as a concave. If reflecting surface is outward, we will consider that surface, that mirror as a convex. Okay, clear? We got these two parts from this spherical mirror. We got these two parts from this spherical mirror. This is also said that it is a quartered region. Okay, quartered region. This is the reflecting surface. This is also reflecting surface. This is inward and this is outward. Now something else. Something else is what? This okay, this here. What is happening here? This between this we will consider as pole. Just before pole we will consider focus. We will consider what? Focus. Just focus we will consider as radius. Okay, and this line is known as principal axis. Now here, this is what? This is pole. This is pole. And just before pole will be what? Focus. And before focus will be what? See, curvature. This is what you have to know. This center of this mirror, this we will consider it as a pole. This focus and this what? This is curvature. What is the radius? Where is the radius? A radius is what? Radius would be from C to P. From here to till here. It is a radius. Clear? From C to P. It is a radius. From here to here. It is a radius. This is P. Just before P is a focus and this is a curvature. Distance from pole to curvature is a radius. Is a radius. Remember. Always remember. That is how. But here you can see it is a reflecting surface. That's why we wrote this here. But this will be here. This side. This will be this side. Okay. You can say here there is a not surface, a space. Here this will be pole and just here it is a force and here this will be curvature. Distance from here to till here is what? Radius. It is a radius. Now we are drawing this side, not this side. Why? Because we consider this a reflecting surface. Reflecting, no, not reflecting surface. This is painted area. So in painted area, inside of a painted area, we will not draw this curvature, focus, this, that. Okay. Where we will draw this curvature. We will find curvature, focus, pole. Where there is a reflecting surface. Okay. Now here, always remember this is center of a curvature. This is a pole. This is a principal axis. Distance between C and P is a radius. Is a radius. Now something else. From here I want to say law of this, law of reflection on this, law of reflection on this will be same as we saw law of reflection of light on a surface plane. Same here, laws will be followed. Same here on this. If light is coming like this, then it will turn like this, of course. So this will be equal to this. This will be equal to this. If light is coming like that, so this will be equal to this, and normal line here. This will be equal to this, like this. These are laws of reflection of light. Okay, this will be same. There is no change. There is no change. Now something else I would like to explain. Just look at this. A special ray of reflection. No, something else. But related to this. Let me draw. No, it is telling a special race for concave mirror. A special race for concave mirror. Here remember for concave mirror. Concave mirror. It means reflecting surface is where? Inward. Inward is what? Inward area is a reflecting surface. This is inward. Now here, always remember a special race. If a ray, if a ray is coming parallel, if a ray is coming parallel, then after hitting on concave mirror, after hitting on concave mirror, what will happen? This ray will turn like this. Will turn like this. Of course, yes, it will happen. If ray is coming parallel, then. So you can say if ray is coming parallel, then this will not reflect parallel. Okay, it will it will go through the focus. It will pass the focus. If ray is parallel, if ray is parallel, remember. Now here, if ray is not parallel, if a ray is what? If a ray is passing the focus, if a ray is hitting on the surface of a concave mirror by passing the focus, then it will turn in by making parallel. You can say it is a passing through the focus. It turn into another direction like this. This is a parallel. This will be parallel when ray will pass the focus. When ray will pass the focus, then this will be parallel. Okay. Here you can see. Here you can see what is happening. Here ray is passing. Ray is passing through the focus, but it will come on the same path. It will come on the same path like this. It will hit, then it will come like this in same direction. In same direction. When light will come like this and will hit on this. Now here what is happening? What is happening here? Here is happening. If okay, no problem. Light is coming and it is falling on the pole of the concave mirror, and if it is happening, then of course it will turn like this. It will turn like this. It will make what? If light is falling on pole, then it will make this I is equal to R. Angle will be equal of both. Clear? Here, ray is coming parallel. That's how it is a passing. That's how it is a passing what focus. Here, this ray is coming by passing the focus, and that's how it is a parallel. Here, it is coming from this side, and it is hitting on the surface of a concave mirror by passing focus. That's why it is turning in same direction. It is turning in same direction. Now in this concave mirror, what is happening? Rays falling on a pole. Rays are falling on a pole of the concave mirror. That's why angle of incidence and angle of reflected ray both will be equal. It will happen when light is falling on pole. When light is falling on pole, yeah, we saw this many times. If light is falling on pole, then both angle of incidence and angle of reflected ray will be equal. These are some special rays for concave mirror. If light is coming parallel, then it will pass the focus. If light is hitting on the surface of a concave mirror by passing focus, then it will turn into a straight direction by making parallel line. Here you can see. Here you can see. It was parallel, then it passed the focus, and it was not parallel. Like this. It passed the focus. That's why it made parallel. Now we saw this. Now let's see image formation by concave mirror. This will be very important, I would say, and this should be interesting. This should be interesting. Image formation by concave mirror. Concave mirror. Concave mirror. You know what is concave mirror? It is a reflecting surface is inward. Okay, is inward. figure. These are five. These are five. Image formation by concave mirror. Let's see what happens in this. You can see. Just have a look for a few seconds. Then I will explain. All these are concave mirrors. First point, you should be clear. All these are concave mirror. We are going to see image formation by all these concave mirror. First is telling you if object is behind the curvature. Curvature is what? It is just a center of the spherical mirror. It is just a center of the spherical mirror. Curvature is the just center of the what? Curvature mirror. Now here, if object is behind the curvature, then what will happen? Light is coming. If object is behind curvature, what will happen? Light will go like this, one ray light like this, and as we saw, if it is a parallel, then of course it will pass the focus. You can see here. This is a, you can see here. This is a ray. If what object is behind curvature, then what will happen? First ray will go like this. This is pole and this is a focus. Now if a ray is a parallel, I am telling you, I am sharing this information with kindly. Now here, if ray is a parallel, now what will happen? As we saw in previous, what? It will pass this focus. This will happen because reason is one ray is a parallel. That's why after hitting on the surface of the concave mirror, it will pass the focus. What will happen? It will pass the focus. Yes. Now what else? One ray light like this. Okay, one ray light, another. So it is going like this. Okay. Another, one more. What will happen? One more here. This like this. This is not parallel. Not in a state. If this is like this ray light is like this, then it will what? It will take back step. After hitting on the surface like this. Okay, like this. And here you can see image formation will be here. Image will be here. Image of this will be here, and image will be inverted. Image will be inverted, which means Inverted, which means what? This is infinity. Inverted, which means opposite, opposite, not straight. Inverted, okay, opposite. If this is like this, then this would be like this, okay, like this, like this. Clear? Opposite, just opposite. This is meaning of the inverted. So here, image is where? Here, and image is a diminished. Image is diminished. Diminished, which means a small, very small. So it will happen when ray light is coming, ray light is going in a straight. It means it is a parallel. Then it will pass the refracted ray will pass the focus, and second like this, second ray. So of course it will take back step, and image will be here. Image will be for here, between here, and image will be dismissed, as well as it will be what? Inverted. Now next, here, object was in this concave mirror. Object was just behind curvature, just behind curvature. Now here in this object is at curvature. Object is at curvature. What will happen now? If object is at curvature, this is P and this is A and this is C. Now object is at curvature. Object is at curvature. Now at curvature. Not this, not that. At curvature. Now what will happen? First ray will go like this. Of course, first ray will go like this. Of course, it is parallel. If it is parallel, so of course reflection ray will pass the focus. Of course, this is a one ray. This is one ray. Now remember, object is at curvature. Main point is what? Object is at curvature. And now one ray is being drawn. One ray is going like this in the straight. Of course, it is a parallel. So if it is a parallel, it will pass the focus. Now second ray. Second ray will be like this. And of course, it will take in this direction. This is a second ray. Now what is happening? Now second incidence ray is passing the focus, and it is also hitting. After passing the focus, it is hitting on the surface of a concave mirror, and it turns into another direction like this. If incidence is passing the focus, then it will make a parallel line like this, like this. Now where will be what? Here you can see this here you can see. This will tell you, this is what? Intersecting view. This is what? Intersecting view. Where is the intersecting view? Here. Here both lines are intersecting. You can see both lines are intersecting. That's why this will be this image of this will be here. Where intersecting view is there. Where here is the intersecting view. Of course, object will be here. Image of this object will be here. Clear? How did we find? Because of intersection view. This is an intersecting view of both ray line. First this is, and second this is. That's why image of object, this object will be here. Clear? Will be here. So remember what? If object is behind the curvature, then image will be between, just image will be before, just before focus. If object is at curvature, then image will be at curvature, just opposite, but image will be inverted. Okay, image will be inverted at curvature but inverted. Clear? Inverted, you can say inverted. Opposite. Okay, clear. And now one ray, of course, it is confirmed that it will pass the, after hitting it will pass the focus, and second ray it will pass the focus, then it will make a parallel. This is done, this is also done. Image formation in this where just before focus. Image formation in this where just at curvature but inverted. Now next this. What about this? Here you are observing one thing. Where is object? Where is the place of object? You would say between C and F. Isn't it? It is happening or not? Yes. We were placing the object just behind the curvature in first concave discussion. In this discussion, we were looking that place of object is at curvature. In this discussion, we are discussing that object is between curvature and focus. Now we will see where will be image. If object is at curvature, image will be at curvature but inverted. If object is behind curvature, so image will be just before focus. Now object is between curvature and focus, so here it is a telling you. Let's see where will be intersecting you. First as you know, this is straight, which is parallel. If it is straight, then of course it will pass the focus. Because it is a parallel. That's why it will pass the focus because it was parallel. It is a parallel. This is one. We should have at least two, so that we can see intersection view. We should have two rays so that we can see intersection view. From intersection view, we can find image. Now second here. So of course this. Okay, and now you can see where. Hold on. This, and let's say this is curvature. Now where is the intersecting view? This is the intersecting view. So of course here will be what? Object. But it will be what? Inverted. Why? Reason is that object is between C and F. That's why it is a what? Where? Just before curvature. According to this intersection view, place of image is here, behind curvature. Now something else. This is complete. Now next, this. What about this? In this, you will realize that image formation is where image formation is infinity, magnified. This is pole, this is force, this is curvature. Now our object, place of our object will be between where? Not between, will be at focus. Will be at focus. It is very to remember where will be object. In first we saw object was just behind curvature. In second we saw object is at curvature. In third we saw object is between C and F. Now we are looking object is at focus, and next we will see that in next we will see object will be between F and P. That's it. That's it. Now here object is where? Here. Object is at focus. 1, 2, 3, 4, 5. 5 you can see. 5. If object is at focus, now let's draw a first simple parallel, and of course it is a parallel, so it will pass the focus, it will cross the focus. This is 1. This is what? This is 1. Remember. Understood? First ray is a parallel. First ray is a parallel. Now second is what? Of course second will not pass the focus. So that's why we will retrace here. We will draw imaginary line. We will draw imaginary line like this. Like this. Here both are parallel. Both are parallel. Parallel, which means both will not intersect to each other. Never both will intersect. That's why it is said image will be magnified. Image will be magnified. Okay. Here you can see. If object is at focus, then another ray we will draw imaginary line, so that we can find where will be image. Now here, that's it. It is a magnified. Image is at infinity. Even we cannot image. Clear? Why infinity? From this principal axis, you can see it is bigger. That's why it will be magnified. Magnified, which means height of the image will be more infinity. Clear? Because of from the principal axis until this line, it is increasing. That's why I am saying height of the image will be more. Here is less, but image will be more. If object is at focus, then image will be, height of image will be very large. Here you can see it was what? Not too much. You can see both are equal. Here you can see both are equal at curvature. Height, I am talking about height. Now let's understand this. What would you like to say about last? About fifth? About this. What is happening in this? In this object is between FP. Object is between F and P. And here we can note okay, like this. Here if object will be F and P, then of course we cannot draw line. So okay, we will have to draw imaginary line by retracing like this. So here you can see in this what is happening, all images are real, all images are real. We can project this on a screen, but in this is inside the image of this is inside the mirror. That's why we will say this is a virtual image. This is virtual image. Virtual, which means we can see only in mirror. Okay, in mirror. We cannot project that image on a screen. That's why. So image formation by concave mirror, you will observe all this. If object is between focus and pole, then there will be, and then image will be virtual. Image will be virtual. If object is behind curvature, then image will be real. If object is at curvature, then we can say image will be real again. If object is between curvature and focus, then now still image will be real. It is a truth, it is a nature, it will happen. Now object is at focus, still it will be real, image will be real. Now place of object is between focus and pole. Now we can easily say image will be virtual. Image will be inside the mirror when object will be between focus and pole. Then clear. Now here in this and in this you can see height of the image is height of the image is big. Height of the image is increasing. Why? Because of both rays are parallel. That's why. Both rays are parallel. That's why. Clear? Clear. We were saying what? Yes. It will happen if a mirror is concave. It will happen if a mirror is concave. Then it will happen. What else? Here you can see image is big. Height of this image is big, not more big, but image of this is big than this object. So of course, because it is a object is a what between F and P. That's why. That's all.